Welcome to the workshop. Today we want to take a look at section 2.4, functions. And we want to build up our concept of functions through the conversation of relations. So this may be a little bit different than you've seen functions presented in the past, say in an algebra course, but overall it's really the same thing. So let's take a look at that. All right, first, remember that a relation is simply a subset of a Cartesian product. So if I have the Cartesian product A cross B, then a relation is just a subset of that Cartesian product. Okay, a relation from A to B is a subset of that. That's what this says right here. And if two things are related, x comma y belongs in the relation, right, an element of the Cartesian product, we can actually write that x is related to y, x r y, where r is just simply the notation for the relation at hand. All right. So for a function is a relation. So a function from A to B is a relation from A to B with a particular property. And what property is that? Well, for each element in the set A, so if we're working from A to B, for each element in A, there is exactly one element y in B such that x is related to y. Okay, so one thing that's very important here is that in our Cartesian product, right, it's going to be every element of A paired with every element of B for the Cartesian product. And so we're just selecting a collection of those items where we have each one of the elements of A is included once, exactly once. So we have 3 comma something, 4 comma something, 5 comma something, and so on, depending on what our A is, of course, because we don't know what A is. It could be real numbers, it could be integers, it could be people, it could be shoes, it could be pencils, right? It's just a set. So this is one way that it's much more general and generic than the conversation in an algebra course. All right. So again, exactly one element y, exactly one element y in B such that x is related to y. Essentially what we have is we have the set A and the set B, and for each individual element in A, it's just being sent to one element in B. Okay, so this is the idea. And if we had this, then we would no longer have a function. It's a relation. A is related to, or this is related to that, and this is related to that one. Okay, call it maybe x. X is related to A and B, A and B. That's a perfectly fine relation, but that's not a good function. X could only be related to A, okay, in order for it to be a function. All right, so let's take a look at a couple of examples here. We've got a set A given to us and a relation. So in this case, it says that the relations are from A to Z. So we want to make sure that we have everything in A and that nothing in A is repeated. Simple as that. So A has 1, 4, 9, 16. So we've got 1, 4, 9, and 16. So we satisfy this part that we have for each element in A. Right, for each x in A, yes, 1, 4, 9, 16. That part is satisfied. The other part that has to be satisfied is that there is exactly one element in B such that x is related to that element. Okay, so in this case, 1 is related to 1. That's fine. 4 is related to -2. That's fine until we get to 4 is related to also +2. That's no good. 4 is not related to exactly one element from the integers. It's related to 2. So this is not a function. Since, let's see here, 4 is related to -2 and 4 is related to +2. So 4 can only be related to one number. Since it's related to 2, it is not a function. All right, what about our next one? Again, we need to check and make sure that all of A is covered. So 1, 2, 3, 4, we need to find as a first coordinate in our ordered pairs. 1, 2, 3, 4. So all of A is covered, and then we just need to make sure that nothing is repeated, right? We can't have any of those things repeated. Let's see, 1, 3. There's no other 1s. 2, 17. There's no other 2s, no other 3s, no other 4s. So we're all set. Let's say, so this is a function, right? It's fine. This is a function. There's no problem there. Fantastic. Let's say just out of curiosity, if this had 217 in here, let's see. Come on, I can get this. There we go. Okay. So if I added 217 in there, then we would have 2 appearing twice. However, we would have 2 still paired with 17. So it's still unique. It's still exactly one thing that 2 is paired with. So that's something that you might encounter, except not really, because this is also not how you would write a set, right? When you write a set, each of the things can only contribute once. So this thing and that thing aren't actually 2 different elements. They are the same element. They're not distinct from one another. Okay, so sets have things listed once and only once. If you want to list something more than once and have them be distinct from one another, say like in the statistics class where you're considering, a set of books where 5 books are the same, right? You're talking about a set, but 5 of the elements are the same. Then you want to consider what's called a multi-set. But in this case, we're just talking about a set, so we can only have one representative for each item. So this is exactly the set that we would have. We couldn't have 217 again. All right, that's just some side notes for your own edification. So I'll see you guys back here in the workshop as we continue taking a look at more examples of functions and further definitions and notations. See you soon.